Hello, my dear students. This is the video regarding physics problem solving because in your CET or NEET you will have at least 7 to 10 some long numericals and also many more short numericals. And by now you will have learned to solve problems and all, but the major difficulty is you may get a wrong answer. And one of the options will be there with wrong answer also because the paper setter knows the expected wrong answers. So you have to be very careful in recognizing if something goes wrong while you solve, and you should also learn to solve without mistakes. So for this you should master the problem solving, and I have made this video. First you should recognize the possible mistakes. That means what mistakes can happen, that you have to recognize. That is very important. So go through this video before your CET this time. And for this to help you, I have taken some 10 examples of problems and I have solved with mistake without telling what is the mistake. So you have to recognize the mistake and you can text it as a comment or mail me. If you like this, you can share with your friends. And for further, if you want to learn more about this, I am planning to have a 2 3 hours short coaching, quick one before your CET. And for details regarding that batch timings and all, you can join the WhatsApp community using the following link. And also I have my YouTube channel Govind Physics, where I have given a different video where a lot of CET shortcuts elimination methods are given. This video is particularly for problem solving only. All the best. Now we will take the examples one by one. The volume, I will go through this quickly. You can slow down the video, short, pause, and go back and all you can do at your convenience. Volume of an ideal gas is V at 100 centigrade. Volume at 200 you have to find under the same pressure. So data is written, and Charles' law for constant pressure you can apply V proportional to T. V1 by T1 equals V2 by T2. Cross multiply, simplify, you will get 2V. That means if the volume is V at 100, it is 2V at 200. That's the answer we are getting. But this is wrong. Find the mistake. Then the second example, an electron is emitted from a photoelectric surface with kinetic energy 2.1 eV. What is its speed? So mass is taken from standard data, or it may be given kinetic energy, velocity to be found. Continuing, kinetic energy is half mv square. So cross multiply and simplify v square and v, you will get the answer 2.15 10 power 15 meter per second. This is wrong. And how do you recognize that something has gone wrong? What has gone wrong? You have to recognize that. Next example, same example done in a different way, same data, and v square, simplify, you will get 7.3 10 power 7. That is the speed. Again, recognize what went wrong. These are the possible mistakes that you may do while solving the problems. Fourth one, diagrammatically also it is represented. Mass m is kept on an uncompressed vertical spring and released. Spring constant k, find the maximum compression. So it is kept at A, released, it comes down and comes to B and stops here. You have to find x. Now we can solve such problems in mechanics by energy method and force method. Whichever method you do, you should get the same answer. So the two answers should agree. Energy method we will do first, using conservation of energy from A to B. So at A, it's not moving, so only potential energy because of gravitation. With respect to B, it is mgx. At B, again it's not moving, no kinetic energy, potential energy of the spring, because gravitation potential at that point is taken as 0. M has stopped at B. So simplifying, you will get x equals 2 mg by k. That is the first answer by energy method. Going further, if you use the force method, at B, M has stopped, so its weight is balanced by spring force. So mg equals kx, simplify, you will get x equals mg by k. Notice that your first answer was 2 mg by k. Two are not agreeing. What went wrong? Now example 5, a pendulum has, this is also represented diagrammatically. So now a bullet of small m hits this pendulum bob of capital M, gets embedded in it, and then because of the impact it goes further, and this m plus m goes up to an angle of 60° maximum and comes back. You have to find this ratio of masses. That is the question. Now going further, it's diagrammatically represented. First we can calculate this value of h. So notice that from the total L you have to subtract L cos 60. So you'll get cos 60 is half, you'll get L by 2. Use conservation of energy from A here and C final. So here you have only kinetic energy half mv square. Finally m plus m has come to a height h and stopped. So potential energy m plus m gh. H is L by 2. Simplifying, you will get the answer for m by m. The option is B. As I have already told, wrong answers are also given as options. This is wrong answer. Correct one is option A. So recognize what went wrong. Then going further, a steel ball of mass 1 kg is released from this point A and it hits the sand at B and gets embedded. After traveling distance C up to C, it stops. So now it stops because of the resistive force of the sand, 20 centimeter in that distance. So you have to find that resistive force, taking G as 10. So going further, this is the data. Using conservation of energy, gravitational potential energy at A is lost because of friction work done over a distance x. So mgh is equal to work done, F into x. Simplifying, you will get F as 100 Newton. This is wrong. Again, find the mistake. Example 7. This is a conical pendulum. You pull a pendulum to the side and push it. It starts rotating like that. And you have to find period of the pendulum. For that, first we'll keep that R ready. So R, you can easily see that is L sin theta. And going further, resolving mg parallel to the thread. This tension is balanced by this force. So it is mg cos theta. And the tension component vertical is balanced by mg. Horizontal becomes the centripetal force. So mr omega square is t sin theta. Now for this R, we will use our earlier equation 1. For T, we will use this equation and simplify. You will get T as 2 pi root L by G cos theta. And this is wrong. How do you recognize that something has gone wrong? And also find the mistake. Example 8. A block rests on a rough inclined plane making an angle 30° with the horizontal. Coefficient of friction between the block and plane is 0.8. Frictional force is given to be 10. Find the mass of the block. So it is diagrammatically represented. This mg is resolved parallel and perpendicular to the plane. Mg sin theta, mg cos theta. And data is written. The reaction force is mg cos theta. Frictional force is mu into normal reaction. So mu mg cos 30. Simplify. You will get mass as 1.44 kg. And this is wrong. Find the mistake. Example 9. This is diagrammatically represented also. This A has 4 Newton weight. Notice that mg together is given as 4 Newton. B is 8 Newton. Kinetic friction for all the surfaces. That means between this AB and also between B and ground, both are 0.25 coefficient. And this, because of the force F, this B comes out. A doesn't move because it is having that string attached to the wall. And the force is such that the B goes with constant speed. What should be that force? Now, writing the free body diagram for A. Normal reaction from B, weight mg acting downwards, T in this string T, and Fa is the frictional force between A and B. Notice that the force we apply is not on A. So this normal reaction is MAG, vertical balance, and frictional force is normal reaction into coefficient of friction, mu MA into G. And free body diagram for B, weight of A is acting downwards from the top. Its weight is acting on the ground, MB into G. Normal reaction from the ground, friction from A is this one, and friction from B between B and ground, and force that we have applied. Now we will have vertical balance. N2 is both weights together, Ma plus Mb into G, and frictional force is mu into this N2, substitute, and net force is this one, F minus F plus Fa and minus Fb, taking the directions. This should be mass of B into its acceleration, and that is acceleration 0 because it's given as constant speed. So simplifying, you will get this F. You can also put values, but this answer is wrong. And how do you recognize something has gone wrong? That is also important. Then example 10, this is a pulley mass system, and it is given that M2, M3 go down, and therefore obviously M1 goes upwards. That is seen in the diagram. Find A. Now we will write one by one free body diagrams. M1, T1 in this string, and A going upwards with acceleration A. M1G is the weight, and because it is going upwards, T1 should be larger. So T1 minus M1G is M1A. Next, free body diagram for the pulley. Notice that pulley cannot be assumed as massless because M and R are given, and it is going with angular acceleration alpha. And because it is turning this way, this one, you can see that. So T2 should be larger. So T2 minus T1 into R is the net torque, should be I alpha. I for a cylindrical pulley is mr square by 2. So simplifying, you will get equation 2. Then free body diagram for M2 going down, T2 from the thread, T3 from the lower thread, M2G its weight. So net downward force is T3 plus M2G minus T2 is its acceleration, M into acceleration. Then free body diagram for this M3, T3 from the thread, M3G weight, acceleration downwards. So net force is Ma, again that is applied. So you'll get 4 equations for all the 4 objects. Now adding all of them, all the T's gets cancelled. Simplify, you'll get the answer for A. So how do you recognize that this is wrong and also tell what went wrong? So these examples are to test whether you can recognize the mistakes and all. These are standard possible mistakes. There are many more like this. I have just taken some 10 examples. So if you like this, like and share this video and also share with your friends. If you want more corrected solutions for this and more examples, as I have already said, you can join a short course, online coaching, 2-3 hours of problem solving tips before CET or NEET. And to get the details of batch and timings and all, you can join the WhatsApp community using the link shown in the red color. Also, you can go to the YouTube channel where you can get the various elimination methods and shortcut methods for your CET and NEET. This is only for problem solving. All the best. Thank you.